I'm Isabella Bedford. I'm an RF engineer with Modelithics, and today we're going to take a deeper dive into understanding Modelithics 3D brick models. 3D EM models are a powerful tool that can be used to simulate the EM fields and the interaction between various components and their environment. But in the case of some components, such as MLCC capacitors, a very fine mesh might be necessary to get an accurate simulation. This can lead to long simulation times and increased computational power required. Also, it can be very difficult to obtain the geometry and material property information generally regarded as manufacturer IP that will be required in setting up the 3D model. If this information is obtained, it can still be difficult to set up the 3D capacitor models. As a solution for designers, Modelithics is now offering 3D brick models. This is a hybrid co-simulation approach for MLCC capacitors and is part of the Modelithics Complete Plus 3D library for ANSYS HFSS. So what are brick models? 3D brick models are standing components for capacitors in the 3D EM simulation environment, and these allow designers to catch coupling effects in their 3D simulations without having to set up the full capacitor model. The internal device parasitics are not accounted for by using brick models alone. They must be used in conjunction with Modelithics CLR library models. A 3D EM circuit co-simulation must be performed using the 3D brick models and the Modelithics CLR library models in order to obtain the complete performance of a circuit. This will be referred to in this presentation as performing a 3D co-simulation. Planar EM co-simulations can provide good simulation and measurement agreement for structures where EM effects are mostly due to PCB layout and/or solder pad interactions. However, when dealing with closely spaced components, planar EM co-simulation may not provide accurate results due to the fact that it's not capturing the component-component interactions. In the following slides, the 3D co-simulation method that we'll describe will provide a simple and practical way to capture these coupling effects for MLCC capacitors in simulation. Brick models are very simple to use. The same process is used to add a 3D brick model to your design as is used for any encrypted 3D component. Open up the HFSS 3D library palette and simply drag and drop the desired model into your design layout in HFSS. Once the 3D layout and EM simulation are complete, the data must be brought into a Nexum circuit design by creating a dynamic link. To do this, right-click on the target Nexum design in the project tree, and then select Add Subcircuit and Add HFSS Link. A dialog box will open with additional options for the creation of this HFSS dynamic link. In the dialog box with additional options for the creation of the HFSS dynamic link, you can now choose the desired frequency sweep and setup if multiple were created, and then click OK to create the HFSS dynamic link. To complete setting up the 3D co-simulation, once the HFSS dynamic link has been added to Nexum, you can add the equivalent circuit models representing the capacitor internals by dragging and dropping the appropriate Modelithics microwave global model from the component library palette. Then simply connect the microwave global models to the desired ports in the EM simulation data. Now the microwave global models must be configured to use the correct substrate, desired part value, and then sim mode, in this case sim mode equals 3, the simplified parasitic model. Once the setup of the microwave global models is complete, they will now account for all of the components' parasitic effects that were left out of the 3D simulation by the brick model. A note on connecting microwave global models in co-simulation when using brick models. You'll notice that once you've created the dynamic link to your HFSS simulation data in your Nexum circuit design, that there will only be one additional port per brick model. This is due to the way that the port is defined in the brick model and is correct. So now the next logical question is, how do you connect a microwave global model, which is a 2-port model, to this 1 port in the EM simulation data? Because of the way ground is defined in the HFSS simulation, you simply need to connect one node of the capacitor to the desired port in the HFSS simulation data, and then ground the other port. This configuration is correct and avoids potential port coupling that can happen if you try to place 2 shunt ports coming down from your pads. For more information on this topic, please see the link at the bottom of this slide. What are some of the advantages of using 3D brick models? This method only requires a single run of the 3D simulation, and capacitance value can be adjusted after the fact in the circuit simulation. This saves the designer a lot of computational time, as well as avoiding the need to create multiple iterations of a 3D design using separate 3D models for different capacitor values. Because of this, the 3D cosimulation method also lends itself quite well to statistical analyses to see the effective part value as well as tolerance on circuit performance. This method also provides good agreement when compared to measurement data and will allow the user to capture the important coupling effects that can be occurring between capacitors as well as their environment that are observed in the measured data. As an initial test, and to build our confidence that the 3D brick models are doing the correct thing, when a 2:1 sized brick model in single shunt configuration on a 3mm FR4 test fixture will be simulated and compared to measurement data. In the 3D cosimulation comparison shown below, a 5.6 picofarad Murata GRM033 capacitor was connected to the EM simulation data. As you can see, the agreement between the measurement data and the 3D cosimulation result is quite good. Now we can move to a more complex example using multiple capacitors that are closely spaced and see how well the brick model is capturing the interactions that are occurring between these components. For the results shown on the right, 3 of 603 sized brick models are placed in shunt configuration on a 50 ohm line using a 16mm Rogers 4003C test fixture. These capacitors are spaced very closely, approximately 10 mils apart from each other, to better demonstrate the coupling effects that are occurring between them. In the circuit simulator, the microwave global model for the 12 picofarad Johansen R14S capacitor is simulated along with the 3D EM data. As a check of the brick model's accuracy in this configuration, an additional 3D simulation of the structure was performed using the Modelithics encrypted 3D model for the same 12 picofarad Johansen R14S capacitors, and this was compared to measurement data. In the results shown in this slide, the measurement data, shown with blue symbols, shows excellent correlation with the 3D cosimulation result, shown with the red line. The full 3D EM simulation that was performed as a comparison is also shown with the green line. As a baseline, we also performed a simulation using only circuit models and no EM data. This is represented by the black dashed line and shows how different the simulation result would be without capturing any of the coupling effects. In conclusion, the 3D brick models are now available as part of the Modelithics Complete plus 3D library for ANSYS HFSS, and they provide a powerful solution for designers who are seeking to simulate MLCC capacitors in their 3D EM simulations to capture coupling effects. They are not only simple to use, but they simulate quickly and give accurate simulation results when combined with Modelithics microwave global models. You can request a free trial today by going to modelithics.com. We hope you enjoyed this video, and for more information on this topic, you may want to read Application Note 78. Thank you.